America has spent years watching for shortages in oil, gasoline, groceries, and housing. But one of the next pressure points may be even more basic. Electricity. Not because the entire country is about to go dark. That would overstate the risk. The concern is more specific. America is asking for more power, faster than parts of the grid can comfortably add it. Data centers are expanding. Artificial intelligence is driving more computing demand. Factories need stable energy. Homes are using more devices. Heat waves and cold snaps can push demand even higher, and the grid cannot expand at the speed of a software update. Power plants take years. Transmission lines take years. Transformers, turbines, permits, grid connections, and skilled workers all take time. So the first sign of an electricity shortage may not be a blackout. It may be a higher bill, a delayed project, a tighter regional grid during extreme weather, or a reliability warning that demand is growing faster than the system can absorb. According to the U.S. Energy Information Administration, U.S. power consumption reached a record 4,195 billion kilowatt-hours in 2025. EIA projects it will rise to 4,248 billion kilowatt-hours in 2026 and 4,379 billion kilowatt-hours in 2027. America is becoming more electric. The question is whether the grid can keep up. For decades, U.S. electricity demand grew slowly. That shaped how utilities, regulators, grid operators, and investors planned the system. Slow growth made the future easier to manage. Now that pattern is changing. The clearest symbol is the data center. The Department of Energy and Lawrence Berkeley National Laboratory reported that data centers used about 4.4% of U.S. electricity in 2023. By 2028, that share could rise to between 6.7% and 12%. Even the low end of that range would mark a major shift. DOE has also said data center load growth has tripled over the past decade and could double or triple by 2028. Data centers are not the whole story, but they make the change visible. The digital economy may feel weightless. A search query, a cloud file, a streaming service, an AI model, all of it appears instant and invisible. Behind it is physical infrastructure. Servers, cooling systems, backup power, land, water, transmission access, and electricity. The cloud still runs on the grid. The pressure reaches beyond technology. EIA projects that commercial computing will grow faster than any other building end use. Computing accounted for about 8% of commercial sector electricity use in 2024 and could reach 20% by 2050. That is not a short-term spike. It is a signal that electricity is becoming a larger input into the American economy. Electricity also has a constraint most consumers rarely think about. It has to be available in the right place, at the right moment. The grid is not built only for average demand. It has to handle the peaks, the hours when homes, businesses, factories, and large power users all need electricity at once. A mild day may not test the system. A heat wave can. A cold snap can. A fast-growing region can. A cluster of new large electricity users can. The North American Electric Reliability Corporation has warned that resource adequacy risks are intensifying across North America as demand growth surges. Its long-term reliability work points to sharply higher projected peak demand over the next decade. That does not mean blackouts are guaranteed. It means the margin for error can shrink. And when the margin shrinks, reliability becomes more expensive. That pressure is already visible in some power markets. In PJM, the largest U.S. grid market, capacity auction prices rose sharply. Reuters reported that prices increased from $28.92 per megawatt day for 2024 to 2025 to $269.92 per megawatt day for 2025 to 2026 in most zones. Capacity prices are not the same as the rate on a household electric bill, but they matter because they reflect the cost of making sure enough power resources are available when the grid needs them. Reuters also reported that PJM projected a recent capacity auction could add 1.5% to 5% to utility bills starting in June 2026 from the capacity portion alone. That is how grid tightness can reach ordinary households, not as a dramatic national shortage, as a cost that moves quietly through the system and eventually lands on the bill. This is why electricity belongs in the same conversation as inflation, housing, insurance, groceries, and debt. For most families, electricity is not optional. A household can delay a vacation. A retiree can cut back on restaurant meals. A small business can postpone a renovation. But homes still need heating, cooling, lighting, refrigeration, laundry, phones, internet, and medical equipment. Businesses need power to operate. Grocery stores need refrigeration. Restaurants need cooking, cooling, and lighting. Offices need servers and air conditioning. Manufacturers need stable electricity to keep equipment running. When electricity becomes tighter or more expensive, the pressure does not stay inside the power sector. It spreads through the economy. For workers, it can influence where projects are built and how quickly factories expand. For investors, it can change the outlook for utilities, generators, infrastructure companies, and data center developers. For retirees and lower-income households, it can make monthly budgeting harder. For small businesses, it can squeeze margins that are already thin. The issue is not only whether the lights stay on. It is whether electricity becomes another structural cost pressure in American life. Solving that problem is difficult because every option has limits. Building more supply sounds simple. In practice, it is not. New gas plants can provide reliable power, but Reuters has reported that gas turbine delivery delays have averaged about 5 years, with costs tripling. That makes quick expansion harder. Solar and storage can be built faster in some cases, and developers have turned more attention to those projects when gas equipment is delayed. But the grid still has to manage timing, location, transmission, storage, and reliability. Transmission lines can move power from where it is generated to where it is needed. But those projects often take years. Local grid upgrades require planning, capital, equipment, and workers. Labor is another bottleneck. Reuters reported that in 2024, 59% of utility employers had difficulty hiring line workers, citing the U.S. Energy and Employment Report. That matters because the grid is not expanded by forecasts. It is built by crews, engineers, operators, and technicians. If there are not enough skilled workers, the build-out slows. Regulators are now examining the pressure from large electricity users. The Federal Energy Regulatory Commission has looked at large loads located near generation, including questions about reliability, affordability, resource adequacy, and customer impacts. Those questions matter because when a large new electricity user connects to the grid, costs have to be assigned. Reliability has to be protected. Existing customers have to be considered. That is the hard part. The country wants the economic benefits of data centers, advanced computing, manufacturing, and electrification. But the grid has physical limits. When those limits are reached, the costs do not disappear. They are shifted, delayed, negotiated, or paid through markets and rates. This is the central tension in America's electricity future. The economy wants power faster than the grid can always deliver it. That does not make a national electricity shortage inevitable. But it does make electricity a new bottleneck. And bottlenecks change decisions. A data center may wait for a grid connection. A factory may choose a region with better power access. A utility may request higher rates to fund upgrades. A grid operator may pay more for capacity. A household may see another increase in the monthly bill. If an electricity shortage emerges, it may not look like empty shelves. It may look like waiting. Waiting for turbines. Waiting for transmission. Waiting for permits. Waiting for interconnection. Waiting for line workers. Waiting for the grid to catch up with the economy being built on top of it. The most realistic outlook is uneven pressure. Some regions may manage demand growth better than others. Some may add generation and transmission quickly enough. Others may face tighter reserve margins, higher capacity costs, or tougher planning decisions during peak demand periods. EIA's projections point to record U.S. power use through 2027. DOE and Lawrence Berkeley's data center estimates point to rapid load growth through 2028. NERC's reliability warnings point to rising adequacy risks as demand grows. None of that proves the country is about to run out of electricity. Together, it shows a system moving into a tighter era. For Americans, the takeaway is simple. Electricity used to feel like background infrastructure. It was just there. Flip the switch, open the store, charge the phone, run the factory. Now it is becoming a central economic constraint. It powers the home. It powers the factory. It powers the server. It powers the grocery store refrigerator, the medical device, the office air conditioner, the cloud platform, and the AI system. The country is asking more from the grid than it has in years. And the grid can grow, but not instantly. That is why America's next shortage may not begin with oil tankers, gas pumps, or empty grocery shelves. It may begin with a quieter signal, a capacity price, a delayed project, a reliability warning, a higher electric bill. The American economy is becoming more electric. Now the grid has to prove it can carry the weight.